He had what I thought was the most interesting project going, the one that had the most, I don't know, innovative future, so I joined his group.
They gave us, I think it was $3,000 to build a mass spectrometer, and we were brave or foolhardy enough to go ahead and do it.
The application of mass spectrometry to biological problems, which was at the time very difficult, was opening up at the time, and it looked like a real bright future.
And the future has been irrevocably changed because of the innovations in improved spectrometry design made by Dr. Ken Standing and Dr. Werner Enns. Together, their work has played an integral role in the transformation of mass spectrometry into an effective tool to study proteins. Working at the University of Manitoba, their research led to advances in time of flight and other key innovations that would eventually lead to multiple international patents and worldwide distribution of commercialized mass spectrometry instruments. Tools vital in the ongoing research work that provide many of the new discoveries in 21st century proteomics. Dr. Ken Standing and Dr. Werner Enns are the 2010 co-recipients of the $100,000 Encana Principal Award.
Before these new methods came out, it was really impossible to say anything very coherent about these large molecules.
And so when you do proteomics now, one of the important tools, one of the pivotal tools really, is mass spectrometry. You take the information from a mass spectrum of a sample containing pure or mixture of proteins, and you compare that mass spectrum to the possible proteins that are in the database generated from the genome sequence. And that helps you identify. So now you can look at healthy tissue, diseased tissue, tissue from one type of strain and another type of strain. And so you can use these identities of proteins to solve biological problems.
And over the next 20 or 30 years, those proteins are going to be really important. And the only way we get to those new therapeutics is with mass spec. And the Standing Enns team has played an important part in developing that terrific technology.
The first step was really getting orthogonal injection to work on time of flight.
You put it into the mass spectrometer so-called orthogonally, in other words, perpendicular to the axis, and then you accelerate it.
But it worked much better when we added collisional cooling. That is, the ions are coming off in all directions. If you add collisional cooling, it cools them down and brings them onto a narrow beam of low energy ions, and that gives you much higher performance and higher sensitivity.
The innovations that they've granted the scientific world have really given us that extra leap up in really understanding how matter is put together. Their technologies, I find, are really innovative in how much they've opened up the breadth of discovery for us. We're no longer just as chemists pointed in one small little area of understanding the wider world. We can now use tools like this to really explore the full diversity of molecular nature. Worldwide, the mass spectrometry industry is a multi-billion-dollar industry, and Canada has been a perennial leader in it, partly through adopting the technologies of the Enns and Standing groups and other innovators in the field in Canada.
The combination of a Canadian company and a Canadian university bringing this to market has been a great success story, I think.
You're striding on the shoulders of others, but if you contribute something that is new, then I think that's innovation.
So I'm very honored and humbled and happy to to have won the award.
They're the model Canadian researchers. They're good teachers, good scientists. They're humble, and they've been able to just develop this technology and bring it forward. They're exactly what all Canadians want.